As the engineering sector in Asia embraces the future of infrastructure management, the integration of digital twin technology has emerged as a transformative force. Digital twins offer dynamic representations of physical assets, unifying data across the infrastructure lifecycle and enhancing collaboration among stakeholders. This shift towards a data-centric approach not only facilitates predictive maintenance and optimizes resource allocation, but also addresses critical challenges such as climate change and urbanization. By leveraging digital twins, organizations can streamline operations, improve decision-making, and ultimately create more resilient infrastructure that meet both current and future demands. We are very pleased to have with us Mr. Oliver Conze, Senior Vice President at Bentley Systems, as our guest speaker at Future IoT. With his extensive knowledge of digital twin applications in infrastructure management, Conze will provide valuable insight into how these technologies can redefine project delivery and operational efficiency. His expertise will highlight the pivotal role digital twins play in fostering collaboration, enhancing performance, and reducing costs, positioning engineering firms in Asia to thrive in an increasingly competitive and complex environment.
A digital twin is really the digital representation of a physical asset, right? This can be your bridge, your linear asset, a railway line, but I think a digital twin has a lot of layers that we are able to bring together. It's not only the engineering data, it's geospatial information, it's IoT data, can be more transactional and enterprise data. So a digital twin is really all these dimensions of data, but ultimately it's a dynamic representation of a physical asset in the real world. So today in the keynotes, I call the digital twin really the great unifier that enables collaboration, right? A more continuous collaboration across the whole life cycle of designing, of building, and of operating infrastructure. So I think really our vision is that this one central digital twin is something everyone works off. So it drives the sharing and the collaboration of data along the infrastructure life cycle. So I think it's quite interesting of the benefits if you're able to preserve all the information that has been built up during design construction and then hand over and as built with a digital twin over to the maintenance operations phase. Because ultimately that can allow you to do things like predictive maintenance. So really running your operations a lot more efficient. It also allows you, when you think about extensions of existing sort of brownfield assets, that you can tap into the digital twins. You don't start from scratch, but you basically can build on all the information that has been collected before. So I think there's a bit of that closed loop, after the handover to maintenance, also before the next construction project to enhance an asset. And that's what the digital twin really allows to close that loop. Yeah, so there are multiple aspects around the benefits of cloud. I think for me, one really critical business aspect is what I call the ease of consumption, right? Making it really easy to consume software application, easy to onboard, easy to set up, to run a project, but also very easy to consume enhancements of a product, right? We as Bentley, we want our users to benefit from the enhancements we do to our product as rapidly and as easily as possible. And cloud is a great enabler for that. When it comes to collaboration, I think cloud, because it's really in a shared environment, it makes the sharing of data a lot easier, as you can easily set up a shared environment. You can onboard multiple stakeholders of a supply chain. So it's really a great environment for sharing of information across the very complex supply chains, across the life cycles, and across different stakeholders of infrastructure projects. Yeah, so I think traditionally there have been rather, I think, siloed tools for each of the phases of infrastructure projects. The design phase somewhat separate from the construction phase, and then definitely with a bigger separation of the operations and maintenance phase. But I think the industry and projects were run more in silos with some handovers and handover friction. And the tools for communication, collaborations, I would say originally were also designed more for the premise of collaboration within these phases. Now I think this is really changing. I think the lines are blurring, and I think design and build, how basically construction and design is really coming together is a trend we see everywhere across the world as a trend, and that's exactly what we also want to enable with our tools, that we kind of break through these walls, these barriers between these different phases, and develop tools that are truly integrated across the entire life cycle, so that they really allow for that collaboration, communication, sharing of information, not only within each of those phases, but also across the whole life cycle. Yeah, I think YI is always a great place to learn from our customers and how they apply our technology and sort of the benefits they receive from that. So we heard yesterday in some of these finalists' presentation, I think a really impressive one was around collaboration and information management from the Ontario Line project, which is a metro project in the city of Toronto. How they, with these tools for better collaboration, had 40 to 50% time savings for information exchange, for reporting. Oftentimes, I hear benefits from our customers in terms of productivity gains of 1 to 2 days a week, if they really manage to probably share. And then this allows, I think there was another project from the construction kind of work stream of a bridge project with the ENI headquarters. And I think they had quite some impressive saving results using 4D as a technology to really do construction planning and scheduling. And that was a cost saving of the whole project of a time saving of 80 to 90% of the time that they originally anticipated to build sort of a bridge project that connected some buildings. So it kind of time went down from 90 to 5 days. So I think these are quite impressive sort of time savings that you accomplish if you reduce that handover friction and allow for much more seamless information exchange. Yeah, no, that's a great question given how obviously dominant that skill gap is. I think anything with our technology we help to enable and drive up productivity plays a real critical role here. And I think in particular, if you are using tools to automate and optimize the more mundane tasks, so the engineering skills can be really focused on where we need them most and not be spent and sometimes wasted on more trivial tasks. We heard a couple of comments today that just the drawing production can easily take 30 to 50% of a project time. And that's something we can automate with tools like AI, and that really frees up resources to spend them where we need them most. So I do think there's a real key role of technology, of an enabler and a driver of productivity via automation and more intelligent ways of doing things. And that can really drive up productivity and play a crucial role in addressing the skills gap. Yeah, so there are multiple aspects. We touched on the cloud side of things, and I think there the criteria of sort of a rapid and easy onboarding of new projects, of new stakeholders in a project, I think is quite key, and it's critical how fast customers can benefit from innovations and enhancements. That's more the cloud aspects, I would say, of the benefits that I think I would recommend for any type of assessment and decisions on technology. There is another element which touches more on the information exchange, the digital twins, and I think that is something where we talk a lot about this week here at YI, which is the openness of our platform. Because these really complex and large infrastructure projects, they have so many stakeholders, and none of these projects has only sort of one technology vendor that is in place. So it's really also from a Bentley perspective, designing this for a world of coexistence, of Bentley, of non-Bentley tools, ensuring interoperability between those tools. And that's where openness and an open platform, which is our iTwin platform, plays a critical role. So I would say for these very long-lasting projects where you need to make sure that you also think 10, 20, 50 years ahead on the data formats that you want to preserve also for the future. I think openness is a really critical element, and interoperability of tools. So you don't have a lock-in into one set of tools, but you can really embrace a broad portfolio of tools that last long with standard and open data formats. I just come out of a panel discussion where we had 3 industry practitioners talking about that essentially digital delivery really becomes the norm, and you absolutely have to do it to not fall back from a competitive standpoint. So with that regard, we clearly see the demand, we see the pull of digital delivery, and digital twins are really fueling this and are really the cornerstone how you capture that data, that you can actually have your deliverables in a digital form and not in a traditional file-based way. And in addition to that, I think the digital and data-centric approach is the key enabler for innovative approaches, what you can do with data. AI is a good example of that. You really need to unlock the information that sits in files and bring that into a digital twin. And that'll enable today already, but also for the future, AI-driven workflows, and they can play a really important role into productivity. And we talked about the skills gap. So I think it's a combination of both, enabling data for AI, and making sure this data is accessible by everyone in your supply chain across the infrastructure lifecycle.